Yes. In today's session, we will see the practical based on thermal analysis. So if you can see in your screen, this is the question for which we will be analyzing the field, that is the thermal field. And if you can see over here, before the conduction is taking place, there is one element where convection is happening. So we need to discretize the problem first. So based on the given data, that is, he says there are three different materials. So based on that, the nodes will be discretized. So node number 1 and 2, therein convection is taking place. Then between node 2 and node 3, conduction is happening. Again between node 3 node 4, again there is one conduction. Between node 4 and node 5, there is another conduction. See, conduction is the same process, but since the constant of conductions are different, so there will be some difference of conduction in these elements, right? And again the basic temperature properties before the start and after the end is shown in the diagram. So same thing we will solve with the practical. You have to launch your mechanical APDL launcher. Wait for it to get launched. Then you have to define the directory where you will be saving your things. So we are doing experiment number 3. So we are defining that directory and write the job title. Anything you can write here. We have written thermal analysis, and then click on the run option, so that there will be a interface of ANSYS that will be starting in front of you. Then as we have already defined the job name and the directory, we'll move on to select the element. So if you can see in the question, we have to select two different elements, as one element will be taking care of the convection and the other element will take care of the conduction. So we will define the element. First of all, we will define which type of analysis we are doing. We are doing thermal analysis. Press on OK. Go to preprocessor, element type, add element. Herein you can add two different elements, like the conduction element and the convection element. So the first thing which is happening is the convection. So select link and convection element. Click on apply if you want to select one more element. Else you click on OK. So click on apply. The element here has been recorded. So now select conduction element. Don't click on apply, because if you click on apply, that element will be reflected here. And if you click on OK, then same element will again get reflected. So click on OK. That screen will close. So we have two elements defined. Close that element type. So two elements are defined as per the given question. Now we have to go for real constant. See, real constant are nothing but the area of the elements that are given to you in the question. Now if you can see in the question, nowhere area is defined, nowhere the area is defined. So what you can do is if area is not defined, you can select unit area, because if you can see in the question, the constant are watts per meter square degree Celsius per meter square. That means the area is unit area. If not defined, you take area as a unit area. So for area, you write 1 over here. For the first material, we are defining the real constant. Click on OK. So set 1 is already there. Add for element 2, link 1 we have defined, link 2 for element 2, you again define the area. Again area for second element is not given, again use unit area. So now see, there are two sets of areas, one for conduction, one for convection. Close this real constant. We have defined the real constant. We will go to the material properties. In the material properties, you have to go to material models. So in the material models, what you need to do is you need to select the constant of conduction and convection. यहाँ पर मटेरियल प्रॉपर्टी मतलब जो मटेरियल आपका कांस्टेंट के हिसाब से चेंज हो रहा है, ठीक है. अगर सपोज स्ट्रक्चरल फील्ड में आप करते हो तो वहां पर यंग्स मॉड्यूलस आपकी मटेरियल प्रॉपर्टी होती है. तो पहले क्या हो रहा है, कन्वेक्शन हो रहा है, तो पहले कन्वेक्शन का मटेरियल प्रॉपर्टी आप डिफाइन करो. तो यू नीड टू गो इन योर क्वेश्चन एंड चेक व्हाट आर द प्रॉपर्टीज गिवन फॉर कन्वेक्शन. So if you can see, the constant of convection is 30 watts per meter square degree Celsius. ये मीटर्स में है, ऑलरेडी वैट्स में है, तो सिर्फ जो उसकी वैल्यू है वो वहां पर आपको लिखना है, दैट इज 30. सो फॉर कन्वेक्शन, go to isotropic material and select the constant, write 30, whatever the value given to you in the question, press on OK. Now see in the question, Ahead of convection, there are conduction. Conduction is happening, but there are three different constants for conduction. So based on that, you have to use that different constant and define your material. So there will be three different material. So press on conductivity, press on isotropic, and based on your given value, that is 25 for first material. Sorry, just wait. See, what is the fault? You don't need to add in the same material. You have to select material, new material, material number 2, and in material number 2 you go for conductivity, and the material property is 25. See in the question, it is 25 watts per meter square Celsius, degree Celsius, 30 and 70. So 25 I have added. Again add new material, then okay, then go to isotropic, and the property is 30. Press on okay, then go on new material, fourth material, go on isotropic, that is 70. Okay, so we have defined 4 different material for our analysis. So real constants are defined, material properties are defined. Don't go into the section part, directly go to the modeling part. Now all the properties are defined. Now we need to create the nodes and join the nodes to create the elements. So go to nodes in active CS. Now before writing anything here, go to the question C. What are the distances and how many nodes are there? There are 5 nodes, 4 elements. Difference between first and second node is not given. So you can plot the nodes on the same point. Then there are some differences. We will count as per that we will plot. So in active CS, node number 1, 0, 0, 0. Click OK. So here your node number 1 is plotted. If you see in your question node number 2, there is no difference, no distance between node number 1 and 2, because the thing happening there is because of convection, जो हवा से हो रही है. तो आप नोड नंबर 1 और नोड नंबर 2 को सेम पॉइंट पर रख सकते हो अगर क्वेश्चन में नहीं बोला है तो. So based on okay, there are 2 nodes on the same point. Now again node number 3, you can see it is at a distance of 0.3. okay, यहाँ पे देख लो आप 0.3 from reference. Then from reference node number 4 is 0.5, node number 5 is 0.65. तो वो भी आपको प्लॉट करना है. यहाँ पे नोड नंबर 3 आपका आ गया है. नोड नंबर 4 it is 0.5. okay, then node number 5 it is 0.65. okay, so see on your screen there are 5 nodes. Now nodes are defined. You need to create or join the nodes to form element. But before joining the nodes, you have to define the properties. So see here, there are 2 different elements, 4 different material set and 2 real constant जो आपने यहाँ पे element type, real constant और material property में define किए वो यहाँ पर आया है. तो पहले तो हमको convection करना है, तो link 34 material 1 real constant 1 ओके करना है. ठीक है, फिर उसको थ्रू नोड्स कनेक्ट करना है एलिमेंट को. प्रेस ऑन दिस, सेलेक्ट. तो सी देयर इज वन कमांड. there are 2 nodes at this location. Pick node number 1. okay, then again select. Again don't select node number 1, go to node number 2 from next and then select okay. That means now what happened, node number 1 and 2 are connected through an element. Same thing you do for element type. Change the element, change the property, change the real constant, press OK. Through element, node number 2, node number 3. Okay, so the nodes are connected to form an element. Now go to element attribute again. Link will remain same, material property will change. Conduction का जो constant है वो change हो जाएगा. Real constant set will remain same. Press OK through nodes. Point number 3, point number 4. Okay, elements are connected. Then element before joining any nodes, go to element attribute and change the properties if required. These 2 are not required to be changed, only the constant is to be changed. Press on OK. Auto number through nodes. Point number 4, point number 5. element properly, go to list, go element, can be area itna. Close this. Now the nodes and elements are created. Now we are done with nodes and element. Now only the boundary conditions are to be incorporated. So go in loads, define loads, go in setting, go in apply. Now for thermal field we have to apply, and temperature where on the nodes. Which node? Node number 1, there is one property, that is temperature. How much the property is? If you see in the question, it is 800. I will show you. This is here, the temperature is 800, here the temperature is 20. So I have selected 800 on node number 5. Okay, the temperature is 20. Okay, so these are the boundary conditions which we have defined. If and see in the question, the loads in this for thermal analysis are temperature only. जैसे स्ट्रक्चरल में फोर्सेस होते हैं, थर्मल में टेम्परेचर्स होते हैं, तो वो हमने डिफाइन कर दिए. अभी हमको क्या करना है, प्री प्रोसेसर का काम हो गया. सोल्यूशन में आपको सॉल्व करना है, बट सॉल्व करने से पहले सोल्यूशन कंट्रोल में आप जाइए और ये स्टेप टाइमिंग जो है उसका वो ऑन कीजिए. ठीक है, स्टेप टाइमिंग से आपका जो रिजल्ट है दैट विल बी प्रीफरेबली इन ए very good dimension. So now the loads are defined, solution is defined, solve, go to solve and press on current OS, commands will come, you press on OK, solution is done. Once the solution is done, that means your solution is the things which you have defined are correct, right? वरना solution में कुछ error देता है वो. ठीक है, प्लॉट कंट्रोल में स्टाइल में जाके आप साइजेस एंड शेप्स में जाके इसको ऑन कर दीजिए तो वो 3D व्यू में आपको दिखाई देंगे. यू कैन व्यू दिस वे द टेम्परेचर्स आर, दिस वे द एलिमेंट्स आर. ठीक है, नाउ इफ यू वांट टू सी द आंसर्स, गो टू जनरल पोस्ट प्रोसेसर, सी read result you can do, or you can plot result, go on control plot, nodal solution, for which nodal solution we are doing, nodal temperatures we are doing, press on OK. So these are the solutions. See, red part indicates 800. So basically here it is red part. You can change the orientation if you want. कहाँ से आपको देखना है, you can change the orientation and see. If you want to zoom, you can zoom from this side. So your temperature is ranging from 800 to 200. The blue one is 200 and the red one is 800. Red one is not seen on the element because it is happening in case of convection. So if you want to see more such list of results, you can go in list results, detailed summary or nodal solution. You can go press on nodal temperature, press on OK. These are the temperatures which are varying from 800 to 20. And if you want to cross check, your temperature 2 is 319, 146 and 50. See, we have solved in the practical lectures 319, 146 and 50. So our answers of temperature are matching with the answers which you are getting over here, right? So these are the answers which you are getting. And more, if you want to explore, you can go in different solution and see what are the answers or the solutions which we are getting. Whatever the solution you want, you can take it from here. And if you want to save the thing which you have solved, you can go to plot control, capture image, the image will come, then you can save that image into some directory if you want. Okay, so this is all about the analysis, thermal analysis of the given element.